A simple introduction to R for market researchers. First of all, what is R? Well, it's an open source free statistical language. It's only used for statistics and for charting and things like that. The core language is there, but it's been expanded with this really super large, enormous collection of libraries which make it really useful. It's available for Windows, for Mac and for Unix. You can find out about R and you can download it from this link on the page here. How do you find out about R? Well, you can use books or you can use articles. There are lots and lots of videos on YouTube and elsewhere, and there are some e-learning courses like DataCamp and Coursera and so on. So there's lots of resources for finding out about R. Most people that I know are using RStudio as the environment to use R. Now, technically it's called an IDE or an integrated development environment. You don't need to worry about that. What RStudio gives you, it gives you an editor, and it's a tidy place to run R. You can see the variables, you can keep everything organized and structured. There are open source and commercial versions of RStudio, that's to say free and not free, and that really depends on whether you're going to be selling the results or not, as a package or not. And you can look into that, or your legal team can look into that, and you can find out more about RStudio and you can download it from the link that's on the web page here. So here is an RStudio page. At the top is where I would put scripts. The bottom left section is the console, and that's where we can type commands, and it's where some of the simple results go. Some of the other results go elsewhere, for example into plots, and we're going to see that shortly. So let's start with commands. You can run R as a computer language. In fact, I'm going to recommend that you mostly do, but you can also use it to do single commands. Traditionally in the programming world we start with hello world, so we just type print hello world, hit the return key, and it will echo hello world back in the console. We could tell it to print hello world, but don't put the quotes, so quote equals false, and that will generate hello world without the quotes around it. Or we could set hello world to a variable, so I've got a variable here called myText. That little less than or equal to, less than symbol followed by a dash is read gets. So myText gets hello world, and then I print myText, and again we get the hello world message. Or I can just type myText and it will echo the contents of that variable to the console, hello world. Of course, it's a computer language, so it has variables. So here I've got two variables that I'm using. A gets the value 2, B gets the value 4, and then I print A times B. And remember, all of this is simply typing it in the console in immediate mode, and the result comes back 8. We can put the results of something like a multiplication into a variable. So C gets the value of A times B, and then when I type C, up it comes as 8. We can also put text in, as I showed you before, so C gets the value hello world, I type C and up comes the value for that variable. R is much more around vectors than it is around individual variables, and a vector is a collection of numbers or collection of strings or a collection of other things. So we have a variable here x, and it gets the results of using C, which is concatenate 1 2 3 4. So I've created a new entity, a vector. It's got 4 elements in it, and those elements are 1 2 3 and 4. I can create a new vector y, and I'm creating that by saying y gets the value of 2 times x, and then I ask it to show me y, and y is 2 4 6 8. If you look further up the page, that's 1 2 3 4 multiplied by 2. We can also have text. We have a wide variety of things in the vectors, but here z gets the concatenation of 1 comma 2 comma 3. I ask it to show me z, and we can see that in z there is the 1, the 2, the 3. Now, something that's really useful when you're learning R is there are lots and lots of data sets that have been included in the language. So MT cars is one of those data sets, and they are great tools for playing around and doing the exercise that are in the books, the articles and the videos. So if I do strut, it tells me what's in the data, and I've just shown you the top two here. There's another 9 sets of information further down the page. It tells me it's a data frame. We're going to talk more about data frames in a moment. There are 32 observations on 11 variables. The first of those variables is mpg, which is miles per gallon, and it shows you the values. The next one is the next one is cylinders, which is to do with how many cylinders the car has. 6, 6, 4, 6, 8. Those are the number of cylinders. And we're going to see more about this data set in a moment. So we can use help to understand what is in a structure, what's in a command, and all sorts of things. We can leverage help by just using the question mark MT cars, and it gives us the top part of the information. There's a lot more information if you actually type it into R. It says this data was extracted from the 1974 Motor Trend US magazine, comprises fuel consumption and 10 other aspects of automobile design. It's got 32 observations, 11 numeric variables. So we can use that to have a little bit of an experiment. It's also an example of a data frame. Now, if R is about vectors, it's also around data frames. Data frames are absolutely central to how we use R, and a data frame is a collection of vectors, and they can hold very different information. So you could have one vector in the structure that holds text, you can have another vector that holds integers, another vector which holds factors, another vector which holds things like the weight of the car and so on. So it's a really tidy way of grouping the information together. The command head mtcars4 just shows me the top 4 things in this data structure. I could have done head mtcars10 and it would have shown me the top 10 things in the data structure. So let's have a look at using a command, and we can take the vector back out of the data frame. So by saying summary mtcars, which is the data set, $mpg, which is use the vector that's called mpg, I can see that the minimum value for the miles per gallon is 10.4 miles per gallon. The first quartile is 15.3, the median is 19.2, the median is 20.9, the third quartile, and the maximum value. So summary will give you an idea of what's in the data, and summary is context sensitive. So if you use summary with a different sort of data type, it will give you a different summary depending on what's in that data. We can also leverage some really simple commands to understand the data, and one of the key things about R is its main purpose is how to find the story in the data, how to have a look and see what the data looks like. So I just type in hist for histogram, mtcars $mpg. It's going to show me a histogram of the miles per gallon. How many cars have got 10 to 15? How many cars have got 15 to 20? Now, there are some more advanced things. We're going to look at some of them and you can find out more later. But that's a really quick way of having just a quick look at the data. So the power in R, as I said earlier, comes from the libraries, not just from the built-in commands. So one of the libraries that you'll see used a lot is ggplot2. For some reason it's frequently called ggplot. Quite often when we call it, the individual subroutines are ggplot, but the package is ggplot2. So we go install.packages and it will pull that down from the website. Then we have to load it. So installing it doesn't load it, it makes it available. So library ggplot2 loads it into memory, and then here is a single command. It's quite a complicated command. You can see at the top that it starts with mtcars. A lot of the rest of this label is to do with naming the axes and naming the variables. And it produces this, and you can see why this is so powerful for understanding the data. We've got a chart where on the left hand side we've got fuel consumption, we've got performance, which is horsepower, along the bottom, and we've asked it to color code and shape code the cylinders. So all the red cars have got 4 cylinders. They have less performance and they have better fuel consumption. The green cars have 6 cylinders. They have less good fuel consumption and they have less good performance. They're in that middle group. And then we have the blue cars, which have 8 cylinders, and we can see that they have lower fuel consumption, but they have variable performance going right up to over 300 horsepower. So a great way of looking at the data and beginning to get an understanding of what's there with a single command. And we can play around with those commands, look at different variables, pulling out the data in lots of ways that are quite exciting. Now, all of that is using it in command mode. And when you're using things like show me a summary, show me the head, the top few things in the file, using the str command, yes, you probably want to do them in the immediate mode, in the command mode. But mostly you should be using scripts. So why are scripts the best way to use R? Well, first of all, you create a record of what you did. So you can do it again, you can go back, you can tweak the code. You find that it wasn't quite what you wanted. You want to go and change those labels. Even as in my case, I make so many typing mistakes, and when I've got the chart finished and it's got some really silly labels, it's so easy to go back and edit the code and it just produces a new set of outputs for me. You can audit the code, or somebody else can audit the code to make sure it really does do what it's supposed to do. You can reuse the code for other projects. And you can put comments in the code. In fact, you absolutely must put comments in the code to make it readable, so when you come back later, or when somebody else comes back later, they can make sense of it and they can understand what's in the data. So here is an example of typing something into the script. I've started it with a comment. Anything that's got a hash followed by some text is going to be a comment. In RStudio, the way I've got it configured, that always comes up as green, which makes it stand up nicely. So let's have a look at putting that together. So this is a comment. I've typed it into the script window. We can see that I've assigned a vector 1, 2, 3, 4 into the variable x, and I put a comment about it. I've put a comment about filling up the variable y, and I've put a result multiplying x with y into z and showing it. And all of those with comments. Now obviously with these I wouldn't need to put comments because I can see what they do. But in more complicated cases you absolutely do want those comments. Now from the script window I could select everything in the script window and run all of it, and it would send the output into the console. Or I could select and run a section of the text there, or I could select a single line and run it. So I've got a lot of choice about how I run the script in the script window. When we run something in the script window, it gets written into the console, and the results, if they are simple results, get written in the console too. So that's an example there. So let's put this together with a slightly more complicated example. So I'm using ggplot again, install, load the library command to load it, and I've put in those bits and pieces. It throws up this picture here. Now where does that picture go? It goes into the plot window. The plot window has got save and it's got export. You can take it into a file, you can put it onto the clipboard and paste it in. So it's super flexible in how you can use it. We can create tables. Now at the moment most of the packages I've looked at would never be nice enough to send to a client, but you can do tables and you can get access to them. And in this example I've used XPSS, so you can see where the name is coming from. I'm using the data MT cars again, so I've put some extra labels in there because the labels that are already in it aren't going to be strong enough, and the command to show a table is just that bottom line in there down at the bottom, and it will throw up a table like this. So we've got the number of cylinders, we've got percentages, we've got the total column, we've got the transmission split by automatic and manual, we've got the engine with a V engine and a straight engine. So we can produce those sorts of tables. It's very much around coding, so if any of you ever used the old-fashioned tables where everything came from scripts and you could control everything, you'll find this very much more natural than the graphical user interface way of doing things. I'm going to show you now another example. I'm going to use a different data set to do this. So this is the iris data set, and this is very famous because it was used by Fisher for some of the examples, and it's around 3 species of iris: the setosa, the veriscolor, and the virginica. And it's been used many times, and there's lots and lots of articles about it, and it's quite useful for things like cluster analysis. So I've got an example here where I've got ggplot to enable me to do some plotting. I've got ggalt to give me some extra options. I've got the data available. I put it into a data frame. So on line 9 there, I'm putting the iris data into a data frame, and on line 11, that's the principal components. It's just one line. PCMod gets the value of prcomp of that data frame. And then I'm just going to show the top 2 values using the head command. And when I do that, we can see there are the factor scores on the first 4 components, the 4 components that we've got, and the rotation and so on. So I've done that. Now the next thing I want to do is I want to show this graphically, and I've borrowed this code from somebody else. There's a lot of borrowing goes on when you're using R. We set up some labels, we separate out the variables, and we call the plot command, and then the last 3 are where we're using that ggalt routine to give some encircling, to draw some circles around the key things. And here's that output, and I think it's really quite nice. So we can see that setosa on the first 2 components, principal component 1, principal component 2, is quite distinct from the other 2 types of iris. And we can see that there is some difference between the blue and the green types of iris. As in our labeling, they're not really blue and green, but also an overlap because, of course, 2 principal components do not completely explain all the variation. So there is some loss in separation when we express this on 2 dimensions. So this is a really quick way of looking at principal components, charting the results. We could do clustering just as easily, charting the results. This is a really fast way of looking, playing with data, exploring what's there, combining numbers with visual clues. So finally, in this brief introduction, I'm just going to show a little bit about text analytics. So I'm loading in some different examples here in terms of the packages. I'm loading in TM, which is used for text mining, word cloud, and a color routine to help me give some nice pretty outputs. First of all, I install those packages, then I use library to load them. And many times when you read books and look at articles about R, they will tell you to hard code into your script file where the text file or the data file is that you're going to read in. I much prefer to have a selector. So read lines, file choose lets me choose a file and send it into the text file. And then when we're doing text analytics, we're working with something called a corpus. So one of the things we have to do is we have to make it a corpus. So we'll take the vector source from the text, and that is going to go into docs for us. And the particular text that I use for this is The Wonderful Wizard of Oz, which was the book that my partner Sue York used a few years ago when she was doing some text analytics. You can download the whole book from the Project Gutenberg project using that link there, and it's a really substantial piece of text for us to play around with. We need to tidy the text up before we do any work with it. So the TM map function takes every forward slash and turns it into a space. On line 20 it takes any @ symbols and turns them into a space. On line 21 it takes any double reverses and turns them into a space. 22 says anything that's in uppercase becomes lowercase. Line 23 removes any numbers. Line 24 removes stop words like the, and so on, because we don't want those to be used in the text analytics. Line 25 removes the punctuation, line 26 removes any extra white spaces. So I've changed quite a few things into spaces, so I might have 4 or 5 spaces in a row. I only want one space, so I want it very tidy. And then I put it into a term matrix, a term document matrix, so that we can have a look at what's going in there. And then I split out the pieces and I ask them to be sorted. When I do that, I can just make a very simple command and show here is the most frequent words. Now, it's the Wizard of Oz. It's not surprising that Dorothy is the most frequently used word, but said is the second most frequently used word. Now, actually, it does have some significance. There is a change in the book where it moves from direct speech to using said. Nevertheless, for us, it's not terribly interesting. And we see further along there's one, and we see also came. So maybe there are some words in there that we want to remove from the text analytics. So we can say, okay, let's remove said, will, won, came, made. And by looking at the words that occur really frequently, we could replace several of them in order to get a tighter picture. And then we'll put a random seed into the word cloud. The word cloud itself is a single line. I've told it that I don't want to rotate it. I want to see a maximum of 50 words. And when I do that, we get a word cloud. And this isn't generated by somebody else. This is something that I've done. I can change it. I can modify it. One or two of you may be interested to see that the woodman is a major character there. In the book, the woodman is not called the Tin Man. He's called the Woodman, even though he's made of tin. So that is one of the differences between the book and the movie. We can also dig a little deeper. So this is another standard thing in the libraries. Find the associations in that term matrix around the word scarecrow. And I've asked it to go no lower than a correlation of 0.15. The top correlations are awkward. So the scarecrow was awkward. He was a friend of the woodman. He was made of straw. He wanted brains. Tin goes back to the woodman. Burn because he was threatened with flames and fire. So we can see all of these patterns emerging out of the data. So that is the super quick introduction. It's free and it's open source. And along with Python, it's really trendy. Massive collection of libraries. So for stats, for text analytics, there are AI tools. You can do neural networks. You can do all sorts of machine code learning. Fantastic range of graphics available too. There is a bit of a steep learning curve. If you can go on a course, that would be the fastest way. If not, expect to spend a few days getting used to it and playing around with it, and probably playing around with some of those data sets that come with R, because they're the ones you will keep seeing in the literature. Sometimes the books have got files you can download and you can play with those too. Make sure you're really good with those before you start doing too much with your data and your particular requirements. It's more about finding the story than telling the story. Not many of the charts, not many of the outputs are things that I would want to use exactly as they are if I were using them with a client. But it's great for finding out what is going on in the data. Lots of resources out there for learning about R. I am actually quite a fan of books. Lots of other people like videos, of course courses as well. There are papers, there are articles. So try and see how you get on. And I look forward to your questions.